you get the impression from the news media that we're breathing pure CO2, or that there's a large amount of CO2 in the atmosphere, and the truth is that there are 38 one-thousandths of 1% of CO2 in the atmosphere. Very small, 380 parts per million. For every million atoms of air, there are only 380 molecules of CO2. And so that has increased from about, 8 one-thousandths of 1% increase in the amount of CO2 in the atmosphere since about 1945, which is when the CO2 emissions started to soar.
Why did they start to soar, in your opinion?
Oh, I think that it's very clear that it's the Industrial Revolution. I don't think anybody would bother to argue that, because the change is so dramatic. After World War II, if you look at the CO2 emissions, they just take off and they soar. They're way beyond what they had been previously, and that's because so many countries began pumping CO2 in the atmosphere as a result of the so-called Industrial Revolution. And so I don't think that there's a big argument about whether the increase in CO2 was man-made or not. I think, but the critical question is, how big is it? And you cannot escape the fact that there is only 8 one-thousandths of 1% increase in atmospheric CO2 since 1945. That's indisputable. And so the question is, what effect does 8 one-thousandths of 1% CO2 in the atmosphere have on climate? And then you look at the so-called greenhouse gas effect, and CO2 is one of the greenhouse gases. Of the greenhouse gases that make our climate warmer and comfortable, and it would otherwise be pretty cold, 95% is caused by water vapor, and only 3.6% is caused by CO2. So the big controlling factor of greenhouse gases is not CO2, it's water vapor, by far. Ratio of 95% to 3%. And so what effect does an 8 one-thousandths of 1% water vapor have on a molecule, CO2, which is responsible for only 3.6% of the greenhouse effect? And the answer is almost none. And then if you look further at the physics of the CO2, CO2 in its absorption capacity of heat is something like a big sponge. And if you have a brand new sponge and you dunk it in some water, it will soak up a lot of water. And then thereafter, there's a limit to how much more water that sponge can soak up. Well, the CO2 that's in the atmosphere right now is pretty much saturated, and you can show with the physics of it that if you were to double the amount of CO2 we have in the atmosphere right now, it would have a less than 1/10 of 1 degree change possible in the greenhouse effect temperature.
Oh, could you say that again? That's so profound. Say it again for us.
Okay, I'm going to say it in bits and pieces.
Okay.
There is so little CO2 in the atmosphere right now that it is a trace gas. There's virtually none. And the rule of thumb is that if you double nothing, you still have nothing. So if we double the amount of CO2 that's in the atmosphere right now, what effect would that have on temperature? Well, the effect would be that the limit of CO2 as a greenhouse gas, it makes up only 3.6% of the greenhouse effect. And so its effect to begin with is limited to about 3%. 95% is water vapor. And so if we change that small effect of CO2, of this minuscule amount of CO2, by 8 one-thousandths of 1%, is that going to cause a 10-degree change in temperature? And you can show the physics that it's incapable. And the bottom line of all this is that CO2, increase in CO2, is incapable of causing more than a very, very small change in atmospheric temperature by itself. So where are they getting this doom and gloom business then if CO2 is not really a big player in all this? And the answer is that in their computer models, they claim that CO2 increase will cause a small increase in temperature, and that will increase the amount of water vapor in the air, and the water vapor will be what causes this catastrophic change in global warming. But the problem is that water vapor isn't changing. Every time it rains, the water vapor content of the air changes. It's a very elusive fact, and there is no evidence whatsoever that there has been any increase in the water vapor content of the atmosphere over this period of of global warming for about the last 30 years or so.
You say 95% of the greenhouse effect is water vapor, 3% is CO2,
Right.
3.6%. What is the rest?
Oh, very, very small amounts of, in terms of greenhouse gases,
Yeah.
Methane, sulfur, various other chemical compounds, which make up small amounts, and together they aggregate the rest of the 100% total.
So I have another question. Let us suppose that all over the world we were to cut CO2 emissions by 50%. What would happen in your opinion?
Nothing. And the reason for that is based partly on what I just said, that the effect of CO2 is so small, it's all about water vapor, not about CO2, that the CO2 change would have virtually no effect. And here's another interesting thing, that even if you suppose that CO2 does have an effect, you can calculate what that effect would be between now and the end of this coming century. And the change is so small that it would amount to way less than a degree, not 10 degrees, at the most optimistic viewpoint of CO2 that you could possibly take. And in order to change the CO2 composition in the atmosphere, there's probably nothing we can do to change it in any kind of a space less than about 500 years. So the total effect of spending trillions of dollars to try to reduce CO2 is going to be absolutely nothing. It isn't going to change the level of CO2 in the atmosphere in this coming century. And so why are we spending then, or wanting to spend, trillions of dollars trying to change CO2 if it's not going to have any effect? And, of course, the answer is, well, look at the politics and look at the money and look at the power, and you'll have your answer.
Did CO2 ever have an effect, either for cooling or for warming, ever on anything?
Oh, it does. The question is not whether or not CO2 has an effect. CO2 is a greenhouse gas.
Okay.
Greenhouse gases tend to cause the atmosphere to be warmer than it would otherwise be without them. The question is not whether CO2 has an effect on climate. The question is how much. And there is so little of it, and it has such a small effect, that even though it has an effect, it is not significant. That's the point.
Okay.
There's no denying that it does have effect, but that effect is very, very small, and by itself cannot produce significant climate changes. And in fact, it's probably the other way around, because by far the greatest reservoir of CO2 is in the oceans, not in the atmosphere. If the climate warms up, the oceans emit more CO2 into the atmosphere. So, in other words, global warming causes more CO2 to be in the atmosphere than would otherwise be. Global cooling causes more CO2 to be taken in by the oceans, and CO2 goes down. And we know this from ice core studies, where during the ice ages, when there were huge glaciers all over the world, and sea levels were lower, we know that during those times the level of CO2 was low. And that when we went from an ice age into an interglacial age, when it was significantly warmer, that as the temperature rose, the atmospheric CO2 rose, but with a lag of about 800 years to the temperature rise. In other words, the temperature rise preceded the rise in CO2, not the other way around. If CO2 were causing it, the CO2 would have to go up first, and then the temperature would go up. But that's not what happened. What happened was that in each of the ice ages, after we went into an interglacial and the climate warmed up, CO2 rose on an average about 800 years later than the temperature rise, and therefore could not possibly have caused the temperature rise, and was in fact an effect of the temperature rise, because it warmed up the oceans, and the oceans then emitted more CO2.
Boy, this is really the opposite of what the story is, isn't it?
Oh, if you look at Al Gore's book, it's a joke, because he claims that, here are the ice ages and here are the interglacials, and the CO2 is a lot higher in interglacial, and so he somehow then infers that, this high CO2 is associated with warmer temperatures, and therefore if our CO2 levels now go up beyond what they were during the interglacials, that we're all going to fry. It's such faulty reasoning. It's totally illogical.
Well, let's talk about the fact that we're entering a cooling period. And for those that wish to prepare, do you think that we could build with different type of materials to be able to survive a profound cooling?
The cooling is not going to be catastrophic.